Alright, this video, the objective is to multiply two matrices. And before I get started, I just want to show you the links for the videos I showed in class about this. One is here, how to organize, add, and multiply matrices. Maybe you want to search for that user. The other is here. It's the animation about matrix multiplication. It uses, I haven't even looked at that right there. And then there's this one, which is a 17-second one, which almost worth looking at again. I like the way that this is how I do matrices. I take the top row of the first one and I turn it to the right. And same thing with the second one, it's the second row, but I just turn it 90 degrees, and that's how I sort of plug them in. All right, well, let's see if that makes sense for us. So our first example basically just asks, is it defined? Is it defined? So if I take this matrix times this matrix, will I get something that's defined? So there's a couple ways to do this. One is the way I was just showing, where you imagine taking the x, y, z and turning it. And if you do that, yeah, that works, right? The x will match with the 1, the y will match with the 5, the z would match with the 9. So that's one way of looking at it and saying, yeah, it's defined. The other way is by telling yourself, what kind of matrix is this? This one is a 2 by 3, 2 rows, 3 columns. This one is a 3 by 4. And if this number matches this number, then it's defined. All right. Same question. Is it defined? So again, if I do it this way, where I just turn it like at 90 degrees. The 1 matches the A, the 2 matches the E, but then I'm out, so I can tell it doesn't match. Another way of looking at it is this is 3 by 2, this is 3 by 4. This number does not match this number, so it's not defined. All right, the next example, we're actually going to start multiplying these. All right, so the first one, it gives me two matrices, and it shows me that let's see if matrices are commutative by multiplication. So first I'm going to multiply A times B, the way I said before. So the 3 goes with the 1, and the 2 goes with the 2. And those two products added together give me my first square. 3 times 1 is 3, 2 times 2 is 4. And those two things added together give me this square. Then I do the same thing, but now the 3 is going to the negative 4, and the 2 is going to the 1. 3 times negative 4 is negative 12. 2 times 1 is 2. Add those together, I get negative 10. Same thing now with negative 1 and 0. First over here, negative 1 and 1 is negative 1, and 2 and 0 is 0. Negative 1 plus 0 is negative 1. Last row, last column. Negative 1 with negative 4 is 4. Plus the second thing has a 0 in it. 0, so 4 plus 0 is 4. So I did some of that in my head, but I hope you got the basic idea. Now let's try it, flipping them around. Okay, this time my 1 and negative 4 go first to the 3 and the negative 1. And I get 3 plus 4 is positive 7. And then now the 1 and the negative 4 to the 2 and the 0, and I get 2. Then the 2 and the 1 to the 3 and the negative 1, I get 6, and negative 1 makes 5. And then the 2 and the 1 to the 2 and the 0, and I get 4. So what do we see? It's not commutative, right? Not commutative. Okay, in our next example, we're going to actually use 3 matrices. We've got A, and the second column is 1, 3. It's hard to read there. 2, negative 1, 1, 3. B here, and then C here. So what they ask us for is A parentheses B plus C. Since addition is easy, let's find what B plus C is first. B plus C, just you add the things together, and you get negative 1, 1, 7, and 4. And then we can multiply that by a. So the 2 and the 2 and the 1, so I always start with that first row and then change and then make it go 90 degrees with it. So 2 and 1 going with the -1 and the 7. So -2 plus 7 is 5. And then over with the 1 and the 4, I'm going to get 6. The -1 and the 3 with the -1 and the 7 makes the -1s make a +1. 7 and the 3 make 21. And add them together, I get 22. And then the -1 with the 1 is -1. The 3 and the 4 make 12. 12 minus 1 is 11. So there's my answer for that one. That's all I'm going to get to right now. We'll revisit this. We'll revisit the word problems on Monday. You want to take a shot at them over the weekend, go ahead. Example 5 on page 210 is where we'll pick up next week.